Welcome to Pre-Calculus, Conics Systems of Equations. So we need a new title page, we need a number, and this graphic should be in your lesson resources. So a system of equations is where two equations intersect each other. And so visually, when you see the diagram on this page, you'll notice that there are 5 different ways that conics can intersect each other. And so here we show a circle and an ellipse. And remember that the answer to the system of equations is an ordered pair, or it could be more than one ordered pair, okay? So they're points. So the question really is, where do these conics intersect each other? And so on this first picture, you'll see that they don't. On the second picture, they intersect one time. On this third one, you see that they intersect twice. On the third picture, or the fourth picture, you see that they intersect 3 times. And on this last picture, you'll see that they intersect 4 times. So it's possible that we end up with 4 different solutions for our system of equations. So today we're going to go over 2 methods, substitution and elimination. We're going to start with the substitution method. So when we're substituting, we want to choose one of the equations to solve for a single variable. Now in this particular problem, both of these equations are already solved for y, which makes it a little bit easier because we don't have to rearrange anything. So what we can do in our substitution is we're going to take the x squared and we're going to substitute it in for the y. So our new equation would look like this. X squared equals 3x minus 2. Actually, you know what? That should actually be over here. So the actual substituting is actually what you see in red right there. So once we substitute that equation from step 1 into the other equation, it looks like what we have here in step 2. And so now we will solve this. And so back in Algebra 2, you went back over how to solve equations of quadratics. And so we should know that we're going to have 2 solutions here. So I'm just going to squeeze this down a little bit. And so we have x squared minus 3x plus 2 equals 0. Factor and solve that. X minus 2, x minus 1. So x equals positive 2 and x equals positive 1. So those are the x values of the ordered pairs that we're going to have as a final solution. So to continue on with that, it says, step 3, substitute what you just found in step 2 into the equation above from step 1. And so step 1, you could really take either equation. Since I can see it on the screen, I'm just going to use y equals 3x minus 2. So I just chose this equation to come down here into step 3. I could have chosen either equation. You can do whichever one you want. It's just the one I can see. So now we're going to take these x equals 2 and x equals 3 and substitute it back into one of those 2 equations. So that's going to look like this. So y equals 3 times the first x value we found was 2. And that comes out to be 6 minus 2 is 4, which gives us one of our answers The x value we used was 2. The y value we found was 4. So that's one of our two answers that we get for our intersecting parabola and line. So the second answer, y equals 3. This time we're going to substitute in a 1. And we're going to get 3 times 1 is 3, minus 2 is 1. So we get our second and final answer here at 1, 1. So that is the system of equations, first example of substitution method. Okay, second example of substitution method for conics. So the first step is deciding, do you want to solve for y? Do you want to solve for x? Do you want to solve for x? Or do you want to solve for y? My suggestion in this problem is you make it as easy as you can and you solve for a variable that you don't have to do much to the variable itself. So in this case, this y is positive and does not have a leading coefficient. So I'm going to take this first equation and I'm going to make it y equals 2x plus 3. And I'm going to substitute that, I'm going to substitute this right here into the y of the second equation. So that gives us x squared minus 2x plus 3 equals 0. Alright, and so now we are going to distribute the negative, which gives us x squared minus 2x minus 3 equals 0. And then our third step is basically, our second step after we substitute, is to solve that and come up with the x values. So we'll do a quick factoring. Three and 1, negative 3 and positive 1. So x equals 3, and x equals negative 1. So those are the x values for our system of equations. The next step would be to choose one of these equations at the top. I'm going to choose this one because it's solved for y. Why not? Make it as simple as you can. And take the x values and plug them in to that equation to get our y value. So y equals 2 times the first x value, which gives me 2 times 3 is 6 plus 3 is 9. So our first ordered pair, we used a 3 and got a 9. And then our second substitution to get our second y value, plug in negative 1. So 2 times negative 1 is negative 2, plus 3 should be 1, giving us our second ordered pair at negative 1, positive 1. All right, so we move on to elimination method now. So we've got two examples of elimination method. So what this problem is saying is you want your x's, your y's, your x squared, all that stuff to line up. And so this problem, it kind of lines up a little bit. It would be nice if this one would have shifted over just a tad. But the goal here is to see if any of the x's or the y's have opposite coefficients. In other words, if they have a positive and a negative. And so if they do, then we can just add the two equations together and some variable will disappear. So in this particular problem, you might notice that the x is positive and this x down here is negative at the same exact time. The y is negative and this y is positive. So if I just go ahead and eliminate, in other words, add these two equations together, right now, the x's eliminate themselves, the y's eliminate themselves, and all we have left is 3x squared equals 12. The 12 is the 4 and the 8 added together. The 3x squared didn't eliminate with anything else. So at that point, now that we have things to solve, things that canceled out, we're just now going to solve the problem. And so in this case, this is a pretty quick solving. We divide by 3. X squared equals 4. We take the square root. When you take a square root, you get two answers. You get x equals 2 and x equals negative 2, which gives us different x values, which tells us that we're going to have multiple answers here. All right, at this point, you got your x values. I'll set up a little spot over here to put our answer. So we have 2, we have negative 2, and now we are substituting. So you can choose, you can go back and choose either one of these equations, whichever one seems easier for you. I'm just going to use the top equation. It seems like there's less work to do there. So x minus y equals 4. So I'm going to use my x values. I'm going to use my 2. And I'm going to plug it into here. And I'll do the same thing with the negative 2. So 2 minus y equals 4. In this case, we're going to subtract 2. Negative y equals 2. And so a positive y would equal a negative 2. So when I plug in a 2, I get a negative 2 as its y value. Alright, so to do our second y value, I'll use the same equation, the x minus y equals 4. I'll use this x value to plug in, this x value over here. So negative 2 minus y, rewrite that for you, minus y equals 4. This time we're going to add 2 to the problem. So negative y equals 6. And we'll change those signs because I don't want a negative y or a positive y, which gives me negative 6 for my second y value, which finishes off the elimination method for example 3. All right, last example on elimination. This problem is all kind of jumbled up, okay? So you notice that the equal signs don't line up, which tells us that the y squared term needs to move to the left-hand side of the equal sign. So let's rewrite that. So we'll have 3x squared plus y squared equals 48. And then x squared minus 2y squared equals 16. All right, so we have the variables lined up now. The x squareds are lined up, the y squareds are lined up. So now we got to take a look at their coefficients. Neither set of these x squareds or y squareds have coefficients that will cancel each other out. So that is now telling us that we have to multiply one of the two equations so that either a y squared or an x squared will cancel. To me, the y squareds are the simpler one to get rid of because you notice that y squared is positive on the top and y squared is negative on the bottom. So if we will multiply the entire top equation by 2, then we'll get a 2 right here, and those two y squareds will cancel out. So let me redo this one more time. So we'll have 6x squared, this is multiplying the top, plus 2y squared equals 96. That was 2 times 3, 2 times y squared, 2 times 48. The bottom equation is going to stay exactly the same. X squared minus 2y equals 16. So now the y squareds will cancel out. That's the elimination in this problem. 7y squared equals, what's that, 112? So 96 plus 16, 112. 96 plus 16 is 112. So we'll continue to solve this equation to get our two x values. 112 divided by 7 is 16. So x squared equals 16, and x will be 4, and it'll be negative 4. So those are two x values, 4 and negative 4. Let's create some separation. All right, you got a lot of different equations that you can choose from to solve for the y variable. In my opinion, just me, I think this bottom one seems the simplest. Doesn't make it right. That's just my opinion. So I'm going to use this equation to plug in for y, to find y. So x squared equals 2y squared plus 16. So that's just my opinion. It's just what I'm going to do. You guys can pick any of the equations that you want. So I'm going to use the 4, this 4 first to solve for my first y value. So 4, I'm going to change that. 4 squared equals 2y squared plus 16. It looks like I'm going to have multiple answers here. So I'm going to subtract the 16. Subtract the 16. That's 4 squared minus 16 gives me 0 equals 2y squared. Divided by 2, I get 0 equals y squared, and y squared equals 0. So once that 0 came about, we just had a whole bunch of zeros left in the equation. So that's one of our x values. Sorry, one of our y values. And so then x squared equals 2y squared plus 16. We'll do that again. We use the negative 4 this time. So negative 4 squared equals 2y squared plus 16. And this is going to do the exact same thing. So I'm going to subtract 16. 16 minus 16 is another 0. So when all that is said and done, gives us another 0. So that is the elimination method for solving systems.